Okay, so can I draw your attention to question 5, part 5, which is this one here. The reason why I want to draw your attention to this one is because it is slightly trickier than the others, okay? Okay, cool. It's slightly trickier than all of the others. Well, let's see. Let's see, shall we? So let's have a think, okay? First of all, what am I going to let u equal? Okay, why not? E to the power of x, okay? So that means then that dv has to be
e over x.
cosine of x, right? Yeah, so I'm letting that one be to the power of x and that one to be cosine of x, okay? So let's have a think. What's dv going to be equal to?
E over x.
Good, excellent. And what's v going to be equal to? Good. Now it might help here to bring up our cycle of derivatives. So let's go sine. If I differentiate it, it goes to cos. If I differentiate that, it goes to negative sine. Differentiate that, it goes to negative cos. Differentiate that, it's back to sine. So that's differentiation, and obviously integration is the other direction. Okay? All right, so let's have a think about this. We've got everything we need. Let's just stick it in the formula. Okay, so I'm going to say the integral of e to the power of x times by cosine of x with respect to x has got to be equal to, well, u times v. U times v has got to be e to the power of x times by sine of x, literally just using this thing here, okay, minus the integral of v du. Let's have a look. V du. Sorry, that was my mistake. That's du. Okay, so v du is going to be e to the x sine of x. Does that make sense? Yeah? Okay, that makes sense. Now let's have a look, because that thing there, I mean that integral there, is that any easier to work out? I mean, it's just another integration by parts, isn't it? It's another product of two functions. It's very similar to what we started with. Well, all right then, let's just do it. Okay, so let's say, right, u is equal to e to the power of x, which means that dv has to be sine of x. Okay, so let's have a think. So if u equals that, what does du have to equal? E to the power of x, right, okay. All right, let's see, so v is equal to, well, let's think, we're at sine, we're integrating, it's going to be negative cos, right? You're like, not sure this is any easier, but let's keep going to make sure. So now we have e to the x times by sine of x, okay, minus, well, now we've have to use integration by parts on this thing here. Does that make sense? Right, so use integration by parts on this thing here. So it's going to be u times v, which is going to be negative e to the x cos x, okay, minus the integral of v du. So minus e to the power of x times by negative, so that becomes a positive, cos of x dx. Does that make sense? Yes, I've literally just said negative cos x, and there was a minus here, so now that becomes a positive. Okay? Why is it never going to end? It's the idea that because we're trying to integrate or differentiate non-polynomial functions, remember e to the power of x, you keep differentiating, it becomes e to the power of x. Okay? Same with sine of x, cyclic differentiable, keeps going round and round in a circle. So in other words, this thing over here is never going to look any easier. But let's have a think. Okay, so we have the integral of e to the power of x times by cosine of x. At the moment, what we're up to, this thing should be equal to, well, this, so e to the power of x sine of x, minus all of this is going to become plus e to the x cosine of x. Then you're taking away this as well, the integral of e to the power of x cosine of x with respect to x. Now just pause for a second. Before we try and do this another time, let's have a look at what we've got. Okay, we have here the integral of an e to the power of x times by cosine of x. Happy with that? Okay. Now where do we start? We started with the same thing, didn't we? Oh, yeah. Yeah? So in other words, these two things are exactly the same. This is interesting, okay? Because if this is like I, this is my integral, and this is I on this side, would you be happy that I could add this to both sides? Yeah? In other words, I'd end up with two lots of my integral on the left. So I'd end up with two lots of my integral, which is just that thing on the left, and then just this thing on the right. So e to the power of x. In fact, I could factorise out here as sine of x plus cosine of x. Does that make sense, what I've done there? I've literally just added that integral on that side, so now I've got two lots of that integral on the left. Okay? Which means that my integral is just going to be half of this. Okay? And I guess I should add a c as well, because of course when I integrate an indefinite integral, I'm expecting a plus c. Does that make sense to everyone? Yeah? Does that make sense? Yeah, so in other words, the integral of this thing is just equal to this thing. Okay? Now it's a bit of a trick. It's a bit of a trick. Okay? It basically involves integration by parts twice and then recognizing, hang on a minute, that thing's exactly the same as that thing. Okay? Because otherwise, you're right, we'll just keep going with this thing because it's cyclic differentiable. It just keeps going round and round and round. Okay? So this thing does actually have an answer. It's equal to this.